set operations. Now you may have seen some of this stuff previously in other classes, maybe not. Let's hope you have. Now the first couple things we're going to look at are called set unions and set intersections. Unions and intersections. This symbol looks like a big old U. So that's a union. So if you see this, A union B, it's a set of all elements in A or B or in both. So as long as it's in one of them, at least one of them, it's in the union. Now the intersection, which is upside down U, A intersect B, has to be common to both A and B. So it has to be in both of them to be in the intersection. Can't just be in just one, has to be in both. And then disjoint, you'll hear me use the word disjoint some. That just means they have no elements in common. Nothing's in common. And complement, denoted by this list A prime. It's everything that's in the universal set that's not in A. The universal set it's the whole set or elements of interest we're looking at. And then A is going to be like potentially like a subset of it. And so A prime would be all elements that are not in A, but are actually in the union. So a way to think of it is not in A. It's called a complement, but think of it as not in A. And then set difference, B minus A, is a set of all elements in B that are not in A. There may be some overlap on some of these sets, like some elements in A may be in B. So if there are, what you're actually doing is you're subtracting those elements in A that are also in B. And a lot of this is kind of confusing when you just look at the definitions. But when you see some examples, it'll make it a lot more sense. So union has to be at least one of them. Intersection has to be in both of them or all of them. Disjoint, they have nothing in common. Complement means not. Difference means subtract away. So let's do some examples. Now I may introduce something in this example that's down here, and they're called Venn diagrams. And so I probably will. It'll make it a lot easier. It's nothing difficult. I'll just say it like that. So we have this universal set, A, B, C, D, E, F, G, H, I, J, K, L, M, X, Y, Z. And you're given that set A is just these elements, A, B, C, D, E, F. B is just D, E, F, G, H. And C is just X, Y, Z. And you're asked to find some sets. So you're asked to find A prime. So A prime is like this. You're looking at the universal set. All these right here. Looking at these. And then what you're going to do is you're going to find A prime. Well, A is all these. So I'm going to take with the A, the B, the C, the D, the E, and the F. That's what the A prime means. It's not A. So whatever is not A is in the A prime. And what's not A is everything that's not A, which is G, H, I, J, K, L, M, X, Y, and Z. That's called A prime. So I'm going to erase that. Let's do the next one. A intersect B. So in this case, we're looking at this set, or these elements and those elements. So intersect B is what do they have in common? Do they have an A in common? No, they do not. Do they both have a B? They do not. They both have a C? No. How about D? Yes. They both have an E? Yes. So as I'm seeing the ones that are common, I'm going to put them in my intersection set. D and E. How about an F? Yes. Since I'm out of elements, so I don't have to look at anything else because there won't be anything else in common. So there's your intersection. That's what they have in common. It has to be in both sets. And then A union B. Now for A union B, as long as it's in one of them, it's in the union. So do we have an A? Yep. You see a B? Put that in there. We see a C, put that in there. You see a D, put that in there. See an E and F, put those in there. D. I've already got the D in there because now I'm now to the B set. I've already got the D in there. I've already have the E in there. I already have the F in there. G, don't have it in there yet. And then the H. So it's in there. A couple more examples. A intersects C. Let's see if we can just look at those without having to do any markings. Let's see if we can come up with the answer with the elements. A intersects C. What do they have in common? Let's see. Let's just do this. See, A is A, B, C, D, E, F, and C is X, Y, Z. I don't see anything in common. Empty set. They have nothing in common. Now the last one is B minus A. So for B minus A, I'm going to start with the B. And watch this. I'm going to go ahead and just write it down. B is D, E, F, G, H. Now, when I say minus A, I'm going to subtract all the elements that are in A. So what's in A that needs to go? So is D in A? Yep. So I got to take that one out. I'm just going to erase it. Is E in A? Yep. Is F in A? Yep. Is G in A? Nope. Is H in A? Nope. So there we go. The answer is just the two elements, G, comma H. Not so bad. But what I am going to do, I'm going to create some space. And I'm going to draw a Venn diagram with this so we can see how that actually looks. What do you think about that? Okay. And you're like, Venn diagram, how do you even say that? I'm not sure what that is right there. Looking back at my stuff. That's the intersection. That should be an intersection. Which one? B minus A? We said it was just G and H. Now I'm going to actually draw this using a Venn diagram. I'm just going to draw a box. And I have three circles, A, B, and C. And it looks like the A and B overlap. I probably need to make those bigger. I'm hoping that I have enough room in here. Then we have a C. So all this outside, I'll call that A. That one B, that one C. Now the reason why I'm drawing it like this is because when I do my A and my B, I'm going to take what I have in common first, which is D, E, F. See those three? So those go in there. That's what they have. That's why I have an overlap, because they have overlapping elements. D, E, F overlap. Now for the A, I have A, B, C also. And then for B, I have G, H. You see that? So I start with the overlapping. And then C has three elements all to itself. X, Y, and Z. Now, the union, which is everything outside of these three circles, is what I haven't used yet. I've used A, B, C, D, E, F, G, H, but I haven't used I, so I can put those anywhere I want outside circles. So I was just putting them up there. I, J, K, L, and M. And the X, Y, Z I have in circle. So if I draw that properly, then this becomes a lot easier. So there's A prime. So to do this A prime, what I would do is I would totally ignore everything in A and include everything else. So if I were to mark it out, if I were to mark those out, what I'll end up having is I, J, K, L, M, G, H, X, Y, Z. So if you do an order, G, H, I, J, K, L, M, X, Y, Z. Well, not what I wanted to do, but that's okay. I'll drop back in there. And then for the intersection A intersect B, we can see the DEF pretty easily. And the A union B, just everything that's in A, it's also in everything in B total. Don't have to be in both, just as long as they're in one. So you have A, B, C, D, E, F, G, H. Then A intersects C. There's nothing intersecting. That's why it's interset. And then B minus A. Then B minus A, what you'll do is you'll take the B circle and you'll actually erase the A and everything that was in it. And just keep the B circle, which would just leave the GH. Because all we had was this. And we just took all that away. Got rid of it all. And it leaves the GH. So that's kind of what Venn diagrams do. We'll do some more examples of Venn diagrams down here, just to give you an idea. So what we're going to do is we're going to use Venn diagrams to do some shading to represent some information. So here we go. So for A prime, if I draw a big old rectangle, put a circle, and call that A, I want to shade A prime. What that means is I would just shade everything outside the A. Does that make sense? Everything outside of it. I like playing with my colors. See that? You get the idea, right? Now for A intersect B, draw a rectangle. I want these two to overlap. Column A and column B. Where the intersection, that's what that means, intersection, where they overlap, right in there. So that's all it is. You're just shading what these represent. Then they intersect B. Or A union B, I mean. We just did the intersection. This is a union. So if it's in at least one of them, it's in the union. So I'm going to shade all of that, all of A. I'm also going to shade all of B. Because if it's in at least one of them, it's in the union. And then A minus B. I want to shade A, but I want to leave the B out. So I'm not going to include it. So I'm going to shade everything in A that's not B. That's what that means. And then A intersect with B prime. That's A. That's B. So we want to do A intersect B prime. This is all of A, but what's not B? Well, this is B. So you may want to do something like this. Let's just use two different colors. I'm going to use a blue. So this is A. Got that? That's A. And then B, or B is this. Everything that's not B is outside the B. And that's everything. So where do these two colors overlap? Right here. Sometimes doing this makes it a little bit easier to see. Or more difficult. But that's what you're doing. So you're taking all of A, intersect it with everything that's not B, where everything that's not B is outside the B circle, which is this portion, which is the same as that one, by the way. Yes, that can mean the same thing. And then A intersect B union C. Let's say I want all these to overlap. So A intersect B is right here. That's where the two circles overlap. That's what intersect means, where they overlap. And then you include all of C, because union means you include all of C. Union is more liberal. It takes everything. It takes all of C. The intersection only takes what they have in common. And that's that one. So now we have another example. And I'm going to bring this up. I'm going to have to shrink it so we can see the whole Venn diagram that's already given to us, so we can answer some questions. So hopefully you can see this. We have just a few questions, and they're all involving numbers. We're going to count. So we're saying in this example that we have 20 elements in this region, 5 in that region, 4 in that one, 8 in that one, 7 in that one, 10 in that one, 15 in that one, and 2 outside. So let's start with the number in A. So for the number of A, what we're going to do is we're going to take all the numbers in A and add them up. So it'll be 20 plus 5 plus 4 plus 8. When you add those up, you should get 37, if I count it correctly. 12 and 5, yeah, 37. So that was those four numbers. Now B intersects C. This is B and this is C. Where they intersect those two. See that? No, I lied. I was looking at A. Don't look at A. Look at C. B and C. We're doing B and C. Where did B and C? Where did the... I guess that's the aqua and the yellow intersect? Right there. So it's going to be 4 plus 7, which is 11. So that's where B and C intersect. Remember, this one is A. So if you lose it, you'll be able to find it. C minus A. Now this is all of C. And we're going to eliminate the A. So we're going to take those out because that's A. Take out all of A. What's left over are these two. So add those two together and we get 17. And then A or B or C. Well, what that looks like to me is it's going to be everything. Except for that number 2. So we're going to add up all those numbers. 20 plus 5 plus 4 plus 8 plus 10 plus 7 plus 15. I might need a calculator for this one. 29, 41, 51, 61, 72, 73. Doesn't hurt to check it again. 20, 30, 45, 50. 60, I got 69 that time. Let's do it again. 29. No, I can't add. Doesn't that bother you? It should be 69, but we'll count again. 25 and 4 is 29. 29 8 37, 47, 54, 69. And it never hurts to use a calculator. Don't you hate that? 20 plus 5 plus 4 plus 8 plus 10 plus 7 plus 15. Yes, I was right the second time. But there you go.